after 8 years of active duty, did some, have done a number of things, was a consultant, did a startup, and it kind of given me an interesting view. When I come back to DOD or come back on active duty, I've been watching DOD from kind of like that having a hybrid civilian view where we did innovation in the civilian world. At Oxford, I did a startup, and I worked with a lot of professors to essentially commercialize their technology, usually through startups. Saw how innovation can work at speed very quickly, and then come back to the government, and it's a very, very different beast. One of the things I found at Oxford, the professors were very good and they had great ideas. They usually failed because the professors didn't understand business. So they had an idea, they had a solution, and they didn't understand how to actually grow for it. If your solution creates $20 of value and costs $30, you're not going anywhere. But if it creates $50 of value and only costs $10 to build, you gotta start. Doesn't mean you can be successful. And then you see when you come over to, once you understand, business has got its own thing on how innovation works, and then you come to look at how innovation works in the government, it's a whole other series of blockers where things go wrong. It's not about necessarily the idea, it's not about the ROI. All of that could be there. You have a great idea that solves a problem, that does something better than before, cheaper, faster, better. We still can't get it into DoD, and it's been interesting to look at where those blockers are in innovation. But I really I come at a lot of this from that background and that perspective of having seen the other side, how innovation works in the private sector and how innovation could work in the DoD if not for the certain blockers. And it's not to say that those blockers aren't there for a reason. Some of the reasons why we do not operate the same way that the private sector does. It's just interesting to see which of those are good reasons and which of those are bad reasons. And when I think about innovation in AI and how AI, what it can do, I go back to innovation is about doing something faster, cheaper, better, less resources potentially. AI has got the ability to bring a lot of that to bear.
Sir, you're a bit muted.
I think you just muted me. Am I
There we
muted
go.
now?
We hear you loud and clear, sir.
Okay. Yeah, no. So when I think about AI and I think about what it can do, it's really about processing data, understanding data and information, and being able to draw from it interesting insights and use it faster, right? So anywhere we have information, anywhere we have data, some of the AI we're developing, that's been developed and we're deploying, and that we're newly developing, what's probably going to come in the future, has got a very significant transformation effect, allow us to do things better. The problem we have, or the challenge we have, is figuring out how to harness that. So with that, I kind of want to talk about how the US Navy has been looking at harnessing AI over the past 2 years and what our path going forward is, and why we think that this is the appropriate, why we've structured this way, why we're going after solving the problem this way, and where we think we're going to go. We'll keep whether I think we'll be successful, how successful we're going to be, we can discuss in a minute. So I don't think anyone at this point doubts that AI has some interesting capabilities that we probably need to be thinking about leveraging. When we started this journey I checked into ONR January of 2020. I actually visited here November 19. In 2019, there hadn't been a Marine Corps reserve debt here, and I was the first reservist to check in. When I got here, they were like, "Do you know anything about AI?" And I said, "Yeah, kind of." And they're like, "Go help Brett. Brett's going to need some help. Brett's standing up the Chief AI Officer of the Navy role, and it's going to need some help." When we started this journey, then we started to talk about what AI was. A lot fewer people had heard of it, even fewer understood it. We had to do a little more convincing back then. The National Security Commission on AI had recently come out. If you've seen it or read it, and I read the whole thing, it's this big, it's a giant binder, 1,000 pages, came out and said the U.S. AI is a national security problem. We are behind. We need to take this seriously, and we need to do it right now and get forward on it. So it was relatively new. The people that knew AI and data science were talking about it, but the rest of the government and the rest of the country really wasn't. So we were put on a clock by the NSCAI that said, by 2020, we want you need to be AI ready, AI enabled by 2025. Doesn't mean you're all the way there, but it means you've put the things in place to allow us to rapidly scale beyond that. The foundation has been built. And as you see, where we were, where we still are, we're still behind. I'll get to that in a little later. We were behind, and this is an exponentially growing technology, and we need to catch up. The longer we wait to get off the blocks to catch up, the farther behind we get, which is something we've been struggling with. I think we've made some interesting strides recently, but we've also had some interesting friction that's come out of over the past couple of years as we try to do this. But the overall goal is we are behind. We got to catch up, and we got to do it quickly. So, and it's also a technology. This isn't about deploying the next generation of submarine or the next generation of aircraft or tank, or if you use an Army example. We're actually quite good at that as a DoD, about the incremental improvement from one platform to the next. It looks like a horrible sausage-making process, and it's got some inefficiencies and friction in it, but the DoD broadly is pretty good at that. Nice 10-year cadence of slowly putting technologies in and deploying them. Where we really struggle is doing that quickly. And when you look at software, data, AI, things that I can go from idea to tool to actually something to have in a week, that's not something we're used to dealing with. Now, we don't have the acquisition process. We don't have any of that. So we were charged with, how do we go after this problem, and what do we need to do to put in place to be successful? And we'll talk through some of the things we've done so far, some of the things we still have left to do, and we certainly have not solved the problem yet. When we talk about AI, I will assume everybody on the call has got a broad terminology on AI, but are not AI experts. Artificial intelligence is an old technology. It's been around for a very long time. I can point to machines that have what I would define as artificial intelligence that have been around for hundreds of years. For those of you that are like, well, I thought AI was new, the first plane flew at Kitty Hawk in 1903. If I were to ask you when the first time AI flew a plane was, have a number in your head. If you're thinking about when that was, I'll give you the answer. It is 1913. In 1913, we had machines that could fly planes in the absence of humans. Now, they didn't fly the whole plane, they didn't fly the whole flight cycle, right? But we were starting to put in autopilot and do that. And that's a machine that's exhibiting a little bit, not as much as we have today, but a little bit of intelligence that's able to do something that only a human could do. Dogs can't fly planes, dolphins can't fly planes, squirrels, you name it, they can't fly planes. But we created a machine in 1913 that could fly a plane under certain conditions. And over the ensuing 100 years, what we've done is expanded the conditions under which a machine can fly a plane, from very level flight to some more different weather conditions, more extreme flight envelope. So that is, when we talk about AI, it's a very broad continuum of how complicated of a problem are we trying to solve with this machine intelligence. And for those of you thinking, well, 1913, we didn't have computers. We did. Computers didn't used to be necessarily digital, right? They are digital today. Before that, they were electronic, and electronic is different than analog. Digital is a different kind of computing than analog computing. And before that, they were people. Our very first computer, when you look at them, ENIAC and things like that, they were automated computers because the first computers were people. That term computer was created to talk about the people that did math for large projects. We'd break them up, put them all in a room, and if you've ever seen the pictures of people, usually in their 20s, sitting and solving math equations, they were the computers. And then the government, and the DoD in particular, is like, well, can we automate this? Can we make a machine that can do all this math? And we called it an automated computer, and then we dropped automated, and now we've got computers. But that spectrum of how we process information and build a machine that can process it in such a way to produce some level of intelligence, that's the broad definition of AI that we use. Machine learning is a very particular piece of that, but machine learning is also your simple linear regression is machine learning at its most basic. We talk about some of these concepts like machine learning and AI. They're very old. They're very old concepts, and we've been doing them for a while. And I think it's important to understand that what we really are seeing is the explosion, or it's the result of the continual drop in the cost of compute, right? Processing power, as we used to call it. The cost of doing math continues to drop at an exponential rate. And Moore's law was originally defined as number of transistors that fit on a chip. And then it was about, well, a few other things about how much it could do. The really best way to think about Moore's law is how much does it cost to do math? That's what's been dropping essentially in half every 2 years. And there's people like end of Moore's law is in sight, end of Moore's law is in sight. My PhD in nanoengineering in the early 2000s, late 90s, the end of Moore's law was in sight then. We still haven't gotten there yet. And even the end of Moore's law, we keep running into certain pieces of the end of this, the end of that, and then we find a way around it. So my personal take is we've probably got another at least 10 more years of Moore's law that we know how to solve. And then beyond that is where it's the unknown, but we've got a lot of clever people figuring it out. So that cost, the drop in cost in computing that's truly driving what we're seeing on AI right now isn't going away anytime soon. So I don't see us being on the end cusp of AI, or we're just passing towards the end of it. I do look at a particular AI application, as it usually goes through an S-curve, right? The individual use case, if you look at the history of like an AI use case, super hard, no way a machine will ever be able to do it. Then there's a 3 to 5 year period where the tools, we develop some new tools, they get really iterated on, they get really good, and then it becomes blatantly obvious that, of course, this was easy, right? So checkers. Chess is a better example for those of you that probably age group wise. Chess was, for many years, there was no way a computer was ever going to be able to solve chess. It was not doable. There were people that said this is just a fundamental problem that computers cannot solve, right? That turned out not to be quite true. The chess playing computer went through an S-curve, totally impossible. Then we kind of went through a phase where it got really good, and now it's solved, right? And chess is okay, cool. That of course that was easy to do. Go, another game that was, the complexity of Go will never be there. Yeah, when we figured it out, and we figured out the algorithms and the cost of the processing and did it. And then people said, well, we're never going to solve poker, right? It's a very complicated game. It's not deterministic rules. You got to read the other player. There's bluffing, and Liberatus solve poker. So when we talk about these use cases, and I think generative AI with ChatGPT and large language models like Bard and Llama that are here now, very similar. They go through this use case, this S-curve of like, never going to happen. This explosive period where we figure out how to make them work, and we iterate on them, they get really good, and then they become passé, right? They're like, of course, that was easy to do. So when we talk about AI, we talk about this broad range of tools and technologies and capabilities that allow us to process information. So much of AI, if you go back and look at the 1970s, would have been futuristic technology to us is blatantly not even considered AI anymore. Google Maps, Apple Maps, the ability to like put in a point, another point, and have it navigate you across the city is something that when it first came out, people were amazed by, and today we don't even consider it AI. That's just a math problem that we solve based on the map. And we take into account traffic conditions. And it's now tied to GPS, so we can kind of update your route. But this isn't AI, it's just simplistic, just basic math. That's a use case of AI that's become so ubiquitous we don't even think about it as AI anymore. A lot of the math and processing that goes into that will kind of goes that way. And I will use that as an example of human machine teaming on what AI is going to do. A lot of people think AI is going to eliminate jobs. People's jobs are going to go away, and that's absolutely incorrect. We've been saying that for 1,000 years, and technology has never eliminated all human jobs. What it does, this is the key part of AI. AI democratizes a job and opens it up from something that only a specialized group of humans can do and broadly allows anyone to do it, or a much wider group of people, which is essentially what a machine does anyway. If I'm going to go dig dirt with my hand, there's only so much dirt I can dig. I get a shovel, I can dig a little more. I get a big backhoe, a big Caterpillar or John Deere, all of a sudden me plus a John Deere can dig a lot more dirt, and it doesn't matter how strong I am. My output is now driven by the output of the machine. So when we talk about AI, as Dr. Graves mentioned, I had the fortune of going to school in the UK for a couple of years after I got off active duty, and used my GI Bill at Oxford. If you go into London, it's about an hour from Oxford. The London road network is, if you've ever looked at it, it's a disaster, right? It doesn't make any sense. To be a London taxi cab driver, you have to take a test that basically proves you've memorized the London road network. It takes taxi drivers 5+ years to study and practice for that before they can pass the test. And it's not an easy test. It's a very difficult test, so they have to basically prove they can navigate from any point to any other point in the city. Once you prove you can do that from memory, you are now authorized to be a taxi cab driver. You get your license. Today, I don't know anything about the London road network, but AI has allowed me to do what it used to take a very specialized human skill set to do. Me plus Google Maps or Apple Maps or some mapping program, and I can navigate a car around London. Which also brings up another interesting point of human machine teaming, which is the machine is very good at the navigation piece. It's still not that good about driving the car. We're getting better at that. But me doing the part I'm good at as a human, which is driving, letting the machine doing the part it's good at is navigating, created a human machine team that basically opened up the ability to be a taxi cab driver to a wide swath of people who otherwise could not have done that because they didn't know how to memorize the road network or that. That's essentially what Uber was. AI enabled, and it allowed anyone to be a taxi cab driver. So it took a small group of people that could do a job and opened it up to everybody. That's what AI is really going to do. And we can talk about how that works for generative AI, and ChatGPT have done the same thing. It used to be hard to write a memo. You had to really think it through and know English. Now you can throw a couple of bullet points into ChatGPT and it spits out a memo. People that used to write for a living and get paid because they were good writers are that's going to be problematic for them. It's going to be good for all the rest of us that suck as writers. We can now generate a pretty good memo based on a couple of bullet points. Don't need to be a great writer anymore. So that democratizes that technology democratizes that skill and opens it up to a much broader set of people. So when we talk about, there's a lot of jibber jabbering from me on this AI slide, but there's a huge piece of AI when we talk about it. It's not just generative AI. It's not just machine learning. It's not just this, that, or the other thing. There's a much broader application of AI to what we do. Sometimes automating a dashboard, being able to pull data from a number of different sources and generate an auto-generated dashboard instead of a PowerPoint is a very rudimentary form of AI, but it's also very useful when you look at a large organization that's constantly making PowerPoints. The robotic process automation piece of automating the workflows of how a DTS transaction works its way through the system. Huge value in being able to do that. Same thing with the banking process. There's also, when we get into this, there's a lot that AI can do. And that's kind of where on the left-hand side of the chart, we talk about all those different pieces of AI, and you see that, potentially the singularity up there. I won't give you my opinion on that right now. But on the right-hand side also is what it takes to make AI work, what it takes for what we think for AI to be for us to be successful at deploying AI, right? And there's a lot of different pieces. So we talk about, this is the AI stack that we got from Carnegie Mellon, put this out from the Software Engineering Institute, about how to think about these different layers. So right, there's the transport layer, and that's how do we get the data. Say I want to put a bunch of buoys out across part of the ocean that have cameras on them and use it to monitor for somebody going through that area. How do I actually deploy AI to do that? We can walk through that use case. So the transport layer is, how do I get the data from the buoy back to whoever is looking at it, or whoever needs to know that there's hey, we just detected a ship transiting this area, or something, maybe a ship, maybe a sub, whatever we're looking for. There's the compute layer in the device layer. Where does the actual computer vision algorithm detection take place, right? So a centralized version of it is the image, the full motion video or the picture goes back to a big cloud, and the cloud does the analysis and says, there is an aircraft carrier in the field of view of my camera, and my camera is sitting at this GPS location, I can see it. Edge-based computing, we can push that algorithm to the edge, so the camera actually is doing all the algorithm, and the only thing it sends back is carrier location. All right, that's how facial recognition cameras work today. They don't actually do the facial recognition in the cloud, they do it on the camera. The camera does two broad things: finds the face in an image, determines if there is a face showing in the image at any given time, and then pulls the template from that and only sends the small template back. Saves a huge amount on data transport. And this is our concept of AI fusion, of how do you balance what happens on the edge and what happens out in a centralized location. As we get into that, there's other layers between the data management, the algorithms, the MLOps pipeline, where some of you may be aware of, is, okay, once I've deployed that model, I probably built that computer vision model in a production environment in the States using a large data facility, right? I'm sitting here. I then trained it on a bunch of images, I got it to work, and I deployed it. So how did I get those little ones and zeros? How did I get the math out to the buoy? Then I get it out there, and then how do I monitor it to see if it's still working? How do I test it and keep it up to date? And if I need to tweak it, how do I roll out the next version? For us on a military application, that's all the kinds of things we need to solve for. And you'll hear a term thrown around a lot, either AI infrastructure or MLOps pipeline. It's a little different than DevSecOps. DevSecOps is more centralized. MLOps takes into account the pipeline of being able to manage that all the way out from central server to end node. But that's broadly how we think about how we're going to get after making AI work in the naval services. And more broadly, this is probably similar to the way the rest of the DoD is thinking about it. So that's what, when we talk about AI, that's what we mean. So how do we want to go after it? First thing I will start with is upper left, right? Mission focused is that the goal is deploy AI to accomplish a mission. We're linking AI to mission. We are not doing AI for AI's sake. We're not doing AI because it's fun. We're doing it because it helps us solve a task, all right, which we call a mission. So when we think about what do we have to do as a mission, you can kind of take it to any kind of command and think through, how could AI help me with that command? If I'm recruiting command, what can AI do to help with recruiting? Right? Identify who I want to recruit. How do I message to them? How do I track them? How do I do training command? How do I do logistics command? How do I do aviation command? If I'm submarine undersea warfare, and I've got all these different commands. So we think about AI as applicable to a commander. Commander has a mission. We start with that, is that we're solving AI for a reason. We broadly, going after this, we've linked this to the CNO's NAV plan, which is one of our main efforts for how we kind of approach this. The NAV plan implementation framework from the CNO is a broad, we'll call it a transformation effort for the Navy. It's got a lot of different lines of effort, from education to recruiting to talent management to retention, warfighting, long-range fires, a whole lot of things that all encompass everything the naval services do, and in particular the Navy in this one. We have focused on, initially the AI focused on four key things of it. but it broadly supports all of it. And then one of the things we're working through the NIF on is what needs to be in place for us to scale, deploy AI at scale, and be successful doing it, again, by 2025. So sometimes it's less about solving an individual use case and more solving for the broad piece of being a AI-enabled service. And on the bottom left, kind of like, hey, where are we thinking of using AI? So we think about the Ds, the dirty, the dangerous, the dull jobs that AI can do, right? You think about, I won't use that example. Those are the kinds of things we can do, we can use AI for, right? So I use the DTS example instead. As opposed to somebody hand checking all the DTS things, we can automate that process. Fraud detection was automated by banks. We can automate a lot of those things that we just do by hand today that we don't need to do. We're also trying to deploy AI, the number 2 there is to fuel autonomy, right? It goes back to when I said that 1913 autopilot was AI, it flew the plane in a very limited flight window. It allowed the pilot to kind of zone out for a little while and would keep the plane on a level heading, altitude, speed, and keep it, in a very tight flight envelope. That was the first form of autonomy, right, or semi-supervised flight by a human. AI is ultimately the brain that's able to allow machines to do things semi-supervised or unsupervised. Your Roomba has a very rudimentary AI in it that allows it to navigate itself around the room. As we deploy some of these other uncrewed systems, when we get into robotics, both to navigate and then do their job, we are trying to develop AI to help them do that. So if you think about a mine hunting robot, it goes out, it needs two broad sets of intelligence. One is how to navigate itself around the ocean as it goes, do its job, similar to the way a Roomba does. And unlike a Roomba, though, when it actually finds something, it needs to know what it's looking for when it potentially has found something. So how can we deploy AI to do both of those things and we take a job that's done today poorly, but do it better with machines? And our third, that's to actually, push out to a robot the decision support tool, speed and quality of decisions. You hear this term DST, decision support tool. That is essentially what Google Maps is for you as a driver. It is a way of helping you solve a problem. You're still the one that's driving the car. Autonomy is if we linked it directly to the car and you're either on the loop or out of the loop. But a decision support tool, that's one way of doing it. We can have those similar things for broad areas of the warfighting area. We can use decision support tools. I won't go into some of the more interesting use cases, but that's where we can use AI for. So that's kind of where we're going after. That's the target of what we're going to do with AI. And kind of the way we're getting after it. As I said before, we're linking AI to mission. That is the first thing we start with. We have a mission. What can AI do for it? Not AI for AI's sake. We have the focus is on scaling it, right? Not one particular use case and solve these little things. We've proven we can solve onesies and twosies here and there. What we need to be able to do is solve this at the level of 1,000 at a time, right? Also, how do we manage the broad, the AI infrastructure? How do we manage that? What happens if units are deploying their own AI, which is not that complicated, right? If you can build your own model, and we expect in the future units to be doing that the same way that if a sailor or Marine has access to Excel, they can do analysis on data they have. Not very many people are good at it, but same thing with AI. If you have access to a data, you could potentially build a new model that meets your particular use case quickly. And how do we manage that to make sure that that doesn't get us into trouble? That fourth one there, big piece on if we rolled out all the machines and all the AI and all MLOps infrastructure tomorrow, it would be the equivalent. I use the example of giving the Taliban a squadron of F-22s. Would they be able to employ them? A little bit. Probably figure out how to make them fly and repair them. They're not that complicated. But there's some things that they would struggle to do without training on them, as well as they didn't have to update their doctrine. right? It's like, well, now you've got aviation you can employ. It's different than just the way you've been doing operations without aviation. So if we rolled out AI, if we had the perfect infrastructure tomorrow and no one that knew how to use it, it would be a tool that just sat in the shed and was used here and there, and you turn around and someone's using it as a doorstop. We've built we're building and are building more key partnerships, both with internal to the United States, where we're leveraging our academic partners, we're leveraging our industry partners, we're leveraging the other services, the broader government community. We're also working very closely with key international partners. You probably heard AUKUS talked about a lot. AUKUS is partly about building nuclear submarines with Australia. It's also partly about working with AI models that can be shared. And when you get into classification of data and no foreign data, it's very hard to actually put the things in place to share the data, to work, to build the models, and to use the models. So part of that is we're working through some of these relationships, some of these engagements with our foreign partners to figure out how to do this and to make sure that a US F-22 or F-35 can talk to a partner allied F-35 and share data in real time as part of a kill web. And that's something that's technically very easy, relatively easy to do from a pure technology, no rule standpoint, but from all the everything on top of it, different nations, different protocols, different rules, different governments, gets very complicated. And that gets into our final thing about, like, we got to make sure the policy is there. Is it 1400 yet? Yeah, past 1400. So DepSecDef today announced the establishment of Task Force Lima. It stood up under CDAO. Task Force Lima is the Department of Defense's AI task force to go look at generative AI broadly, and large language models in particular, and how it would be applicable for the Department of Defense use. So I think that memo should be, so the embargo was lifted at 1400, so hopefully it's been out there. Not a pretty short memo, a couple pages long, but that's going to get into policy, right? ChatGPT opened up a can of worms. On one hand, it's quite simple. Do not put anything other than distro A info into ChatGPT. Do not put any information, any government QE information on a system that's not authorized to hold that data. Broadly speaking, you're fine. But the complexity, the devil is in the details. In some of these models, for those of you that don't know, OpenAI created ChatGPT. OpenAI has a very close partnership with Microsoft. Microsoft owns a portion of them. They're an investor over the years. And they also have a partnership to roll out all of OpenAI's tools into O365, what the Navy call Flank Speed, Outlook, that whole Office suite of applications. They're already built into it. They're just not necessarily turned on for individual users. But they have very powerful tools built in that aren't turned on yet. It'd be great to turn them on if we could figure out how to make sure that we can use them in accordance with our responsible AI principles, as well as in accordance with sharing of information and protecting of government information principles as well. So the ways, talk to a couple of these that are kind of interesting. I mentioned AI fusion. It was where do we put the compute? Where do we put the data? How do we move it back and forth? As we go to a more distributed environment, that's going to get more interesting. For those of you that have ever played with your phone, if you want to know when Siri is able to answer a question based on having access to the internet or not, ask Siri a question when you're on the internet, ask Siri questions when you're not on the internet, and see when you can't get an answer because she doesn't have access to the internet, right? So what happens to an AI model that's requiring or leveraging compute power way back somewhere in a data center on the other side of the world, and we lose that communication pipeline? How do we make sure that critical things happen in a DDoS environment? That's a more difficult software problem to solve with this infrastructure, and so that's one of the things that we're going to have to get out there. I talked about AI maturity, different use cases. AI matures at different rates. We solve chess, we solve Go, we solve poker. There's still games out there we haven't solved, right? And there will probably some it may take longer to solve certain games than others. And the interesting thing about AI is that when you go through one of these S curves on solving it, it's really hard to tell what's going to get solved in the next 2 years. Which of these ones we think is impossible is going to be, oh, that's easy. Generative AI is like, language was like, this is very complicated. AI is never going to be able to do this. And now it's like, yeah, it can. It's just actually, we cracked the nut on the statistical relationship of the words. Still don't have any idea what any of the words mean, but it can spit out text that sounds interesting, even having no idea what it's doing. We're using DevSecOps and MLOps. The AI engineering piece is a broader thing about the particular skill sets required and how you do it. Prompt engineering, you may have heard as a term coming out. It's like, how do you ask ChatGPT a question in such a way that it spits out the answer you want? There was a lot of talk that maybe that was going to become a new job for a while. The ability to ask ChatGPT a question in the right manner. We'll see how long that lasts. And but that's the kind of the ways we're doing. And I'll talk a bit about the means, a nice DoD strategic framework. Data is absolutely critical. Not all AI requires data. Most of it does. Much of it does. There are some interesting use cases of AI that require zero data. If you've heard of AlphaGo, you may have heard of AlphaGo Zero. The zero was there was zero data AlphaGo Zero needed to teach itself to play Go. So not all AI requires massive amounts of data. Much of the interesting ones we're working with today do. There are some use cases that don't, but broadly speaking, what we're going after as well is being able to analyze our data, or draw insight and understanding from the data we have. So it's critical that we recognize that our data is key. We have it on here as data as a strategic resource. It was, what is the current terminology? Not data as a resource. I'm blanking on it. It was like data as a product, right? That our data infrastructure will produce data as a product when it's needed for use, which then allows us to use it to fuel AI, right? And that's where, if we can do that, because that's really what the fuel of AI, a lot of AI is that data. So part of that gets into policy, like who owns it? DecSepDef signed a memo and she said, none of you own your data. The Department of Defense owns all the Department of Defense's data. The fleet, the aviation units, the Army, none of you own your data, so stop preventing anyone from having access to your data. Now, that memo has been signed. There are still massive headaches with actually anyone getting access to their data. Everyone's still treating it very much as in a lot of circumstances, as close hold. We have to fix that. And then once we get access to that data, we build the models on it. We were able to build a model that works and deploy it, and how do we manage that? So on the Navy side, I'll talk about the organization a little bit. We had a project a few years ago called Avenger, named after the type of plane from the Battle of Midway. What we did was, it's in 2020, we took some small task organized teams, what we called a DevRon, or Development Squadron, of an AI engineer, data engineer, graphic user interface, and went after 8 problems. And I've actually got them on my wall here. Streamline contracting, human resources, a small unit maneuver problem for the SEALs, installation protection, maintenance data, readiness, base access, and knowledge management. 8 broad problems. Deployed a task organized AI, SWAT team to go after solving it, and we were mostly successful. A couple of them we struggled on because the data wasn't there. But the goal was not necessarily to be successful, it was to show where was the blocker in being successful. None of them transitioned to a program of record. So even though we were able to solve the problem temporarily, we weren't able to solve it long-term or scale that partly because of the acquisition problems, partly because we didn't know who was going to own the data long-term. It was a really interesting, but it also proved we can deploy AI models to solve almost any problem we want to, if it's the right thing, if we put the right team together to do it. The question is, how do we build the organization that can do that? So we created Navy AI task forces, and there's 6 at TICOMs, 2 more are nascently standing up, and there's 4 at some numbered fleets. And what they are is they sit across the Navy and at these senior commander levels with the mission of what can AI do for that commander? What can AI do for submarine forces? What can AI do for surface forces, for aviation, for special warfare? And to sort of like really kind of take that inventory of what we should be doing and start to prioritize that and kind of oversee the AI going in each of those areas. We've also built, or in the process of building out, the Naval AI Accelerator. The Navy Marine Corps have the Naval Postgraduate School out in Monterey, California, which has is the #1 rated operations research program in the world. So the MBA program, not so much, but there's better MBA programs. When it comes to operational research and a few other things, it's very, very good. And we send sailors and Marines and other services through there. And those OR grads are essentially coming out as AI SMEs, as do, depending on the computer science program in particular, but a lot of them are getting AI, coming out with AI expertise, moves, modeling and simulation. There's one more, EE gets it a little bit. We're creating these AI SMEs. A lot of times we don't use them. About 20% of them do a payback tour doing AI, which is something that we're looking to fix. We're also building the Naval AI Accelerator at NPS to basically better harness this talent, get them plugged into fleet problems earlier in their academic career. They're there for 2 years for the most part. But get them working on fleet problems, one, to better broaden and deepen their education, two, solve a problem for the fleet, and three, pipeline them into that fleet work earlier in their career so when they hit the fleet, they're ready to start working on it. And then also create a feedback loop of what's working in the fleet, what isn't, get that back to the educational institution to make sure that we're teaching the particular skill sets that they need to have when they get out to actually do this. So that's how, on the Navy side, CDAO up at the broader DoD level, obviously CDAO is doing a ton of stuff on AI and data, and we're hip to hip with them. We're leveraging Tradewin, which is an OTA, the ability to Tradewin is an OTA where if a vendor goes to CDAO with a product, CDAO will bless off on it or basically approve it, and then you can then buy it as necessary through Tradewin. So kind of like pre-clear some of these things. And again, the technology we're looking to use is mostly talked through a lot of these things so far. The stack, what is it going to look like for an infrastructure? You know, there's the number of different AI data infrastructures are being built. And right now, a lot of our data is stored on servers, in basements, you know, and it's not in the cloud. Getting it into the cloud is one thing, but once it's in the cloud, how can I access it? Great, I got all of our fuel data or fuel farm data into the cloud. I want to build a log ops tool that accesses that. And I want it to be deployed, I wanted to use it in a deployed environment to understand what my throughput of logistics might look like. How do I access all that? How do I do it? That's something we have to solve. So that's kind of where we are. There's a couple of more slides that I've mostly talked to. I kind of really covered the AI fusion piece, but it's about the example I like to give for what does AI fusion mean. The Marine Corps built a system called GCSS Marine Corps, Global Combat Supply something, but it's basically a logistics and supply AI data management tool designed to do some stuff but work, you know, for the Marine Corps. And we call ourselves the world's, you know, expeditionary force. And we rolled this thing out and it didn't work in an expeditionary environment. We're great in CONUS where we had big fat pipelines. When I deployed to Iraq in 2007 for the first time, we didn't use it there. We didn't use it in 8, didn't use it in 9 in Afghanistan. It didn't work on a ship. It needed a big pipeline. It needed a big bandwidth to work. We've solved problems similarly in the sense that if we can solve that if we want to, if you're browsing a website on your phone, it'll recognize that you're on a mobile device and send you a different web page, stripped down, both visually different, as a lot of times was a smaller chunk of data as well, knowing you're bandwidth limited. We can build infrastructure for the DoD that does this. And we, you know, doesn't mean we don't take advantage of the big fat pipes we've got in CONUS, but it also means we need to make sure that these things work when we are in a expeditionary deployed and DDoS environment where we may not have access to all this? And how does it work if we don't get reach back capabilities or have to be very limited in our bandwidth in an IMCON situation? So that's something that we have to build that private sector does not have to worry about to the same extent we do. The putting everything together, that's kind of where mostly I've kind of covered everything here, but we've got to make sure all this stuff works together. And that's kind of the really interesting, that's where the rub on this is difficult, is that in siloed areas, we're very good at stuff, but how do you pull it all together? How do you get a deployed ship able to build a model that accesses data across the world, share that, what they're seeing, and share that, and do it across the services, right? If we're looking at an Intel tool, are we able to pull all the different data feeds from different Intel sensors around the world to create a common site picture of a user in a particular part of the world? Or does it actually have to go through a person? Does it actually have to get printed out and shared, and not the best way to do it? So that's something we're working to solve as we pull it all together. The four horsemen, Dr. Chris Demchek at the Naval War College just talked about the four horsemen of this. It's like, how do you scale it? You know, we got to be able to do this at scale. We got to do it at speed. We got to be coherent. It's got to be resilient, right? There's a lot of, we didn't really talk about AI and the brittleness of it. It's very easy to roll out an AI model that does something that only works in a very narrow range, and that's very brittle, and that we call it brittle, that it's not resilient. There's a lot of things that work only in that very particular narrow range. That's kind of the reason why AI over the years has been a very niche thing. It works in this very narrow thing. The very first chatbot that came out was in the 1960s, Eliza. And it worked pretty good. People actually thought it was good, but it was a psychology chatbot. It had a few built-in questions. It was able to recognize a couple of things. It would be like, so, and it was able to, people would talk to it. You could kind of tell it wasn't a person, but it worked pretty well. 1960s. Now it took 60 years, we got ChatGPT out, but Eliza only worked in a very, very, very particular set of circumstances. If you asked it questions outside of what it was designed to do, it failed immediately. ChatGPT, you can ask it almost anything, and it's pretty good. There's a few and people go look for reasons where it fails. But that's kind of where as AI gets better, it works in a broader and broader and broader range, right? So it becomes more resilient, less brittle. Last bit, I'll just kind of give you an overview of the task forces we stood up. There's the 7 on here, the 6 of which are at TICOMs, the 7th of which you may have heard of Task Force 59. We've also got Task Force Deep Blue Sea at 10th Fleet, which is Navy Cyber Command. We've got a task force out at 4th Fleet, NAV South, Southcom, JADF South, actually, that's working with AI. We've got a couple of task forces in the process of being set up at BUMED in Navy Medicine, as well as our N1 manpower potentially focused task force. They're thinking through what that would look like. And there's a lot of things on the people side of the business that AI is very applicable to. A lot of things it can go wrong on, absolutely. And it's very, be very careful with AI when it comes to people, but there's tons and tons of applications of AI about how we manage careers and things like that, where good use cases that aren't as necessarily get us in trouble. So they're looking at what that could look like. Last couple of slides, I won't really talk to these. This is pretty much the end of it, and we left it as the, the NSCAI report. We were get after it. 2025, you will be an AI-enabled service, and it's fiscal year, calendar year, at the beginning or the end, but we're certainly getting a lot closer than we were when we started this in 2020. 2025 felt like a long time away. If you think the beginning of FY 2025 is, looking at my calendar, 13 and a half months from now. So we'll see if we get to AI enabled by then. That is everything I've got. That is the overall kind of how the Navy is getting after AI. So happy to, after having talked for 50 minutes, happy to open up for any questions, comments, open discussion.
Oh, thank you, Dr. Long. We do have some questions. Do post in the chat. Question number 1 from Joseph M. Do you see code in the same manner as data and models or baked into those two buckets? He sees some vendor lock around the ETL, ELT pipelines despite DoD owning, quote, the data.
Do I see? Yes. Okay, first of all, there is our industry partners certainly like to lock us in, right? Like I said, I was a reservist. I worked for a government, an company that we sold products to the government. We would sit around a table and think about, all right, how do we sell something to the government that locks us in so they have to use us for the next 20 years? And we were really good at it, right? We knew exactly what to sell so that you were locked into us, and exactly how to structure it so that it got around the acquisition rules, so we were basically locked into our product, and then how to squeeze somebody else out, right? So if you think the private sector is not doing that, they are, like I said, and if you go get an MBA like I did at Oxford, you learn exactly how to think about Porter's 5 Force system strategy and lock in, and like how do you minimize customer churn by what are you really selling them that makes it super hard for them to change. So our industry partners are certainly doing that and doing it, massively. Part of what we have to be careful on that, and I think that's part of our acquisition rules that are going to drive that. The data, our data, we can be certainly collaborative. You take our data, build a model off our data, and use it for something else. I don't know where that sits on the rules right now. Part of like one of the arguments with ChatGPT and stuff is it was trained on like the internet. A lot of people put stuff on the internet that was used to train ChatGPT. The writers strike out in Hollywood right now. They're arguing over, hey, I don't ever want my work to be used to train an AI, or I don't ever want an AI that's been trained on my work to, be able to use that. The problem with that is like everybody's trained on everything, right? If you take a writer, where did they get their ideas from? They got it from the broad swath of society, whether they were copyrighted or not. When we think about the data and like what does this mean of like who owns the data, we have to be careful about that. There's certainly vendor lock-in we have to be careful with. The goal and where do you put the open source pieces of it? How do you build stuff that is more open source, that it allows competition, right? So if we have our data and we let our vendors build models off of, we keep the data and we try different vendors like Marine Corps Warfighting Laboratories trying to stand up an AI sandbox. We've got a big chunk of data. You bring your model, you can build on it, play with it, test it, and if it works, we would be interested in potentially using it, buying it, whatnot. The question is, okay, what happens to that model? Who owns the model, right? So that's an open thing. And again, I poke at how industry is certainly trying to fleece us, but they also have shareholders, and this is a capitalist system, right? And one of the things I used to tell professors when I would work with them to build a business, if you can't make a profit, you can't get investment. If you can't make a profit, you can't stay in business, right? And investment, if you are not profitable enough of an investment, no one will invest in you. So if you are trying to entice someone to build a product for you, you've got to do it in a way that entices them to make enough of a profit to make it worth their while, right? And money is very fungible. So if the investments in defense technology are not profitable enough, people will go invest in something else. And that's just and it's probably your retirement money that's in that investment account that, the people you're paying to manage it go find the best investment. So I hope that answered the question.
Just like everything else, you just pointed out how entangled all of this is. It's very rarely black and white and cut and dry. So let's move on to Michael G., who asked, speaking of which, not cut and dry, in 2021, the Air Force released a responsible use of AI strategy. concerning ethics and how AI is used and employed. Does the Navy have something similar or similar guidance?
It is in development. Yes, it has not been signed. There's a version floating around that I think the very first version may or may not have been cut and pasted off the Air Force version, and certainly developed more. One of the things I think we've been talking about that for a while, especially, let me rephrase that. Are we talking LLMs, generative AI, or AI in general?
He's talking about the AI in general because this came out in 2021, so.
Okay, yeah, our policy basically is use the DoD responsible AI principles. I have them on my wall as well. Responsible, equitable, traceable, reliable, governable. We do, sitting over here too, there's the responsible AI pathway from OSDR&E. Dr. Kim Sablam is a trusted AI and autonomy is leading that. So essentially, DoD has put out a policy, if you're going to use AI, do it in these manners, and we follow that.
Sounds great.
The other one I was referring to was large language models, which is coming, and then Task Force Lima was announced today. So it should be, because CDAO has taken the lead on that one, we got to a version of the large language model policy, and we decided, hey, before we just stick something out a week before CDAO does, maybe we should see what they put out.
Sounds good. Look forward to reviewing what they've put out. Question 3. It doesn't. I'm not really sure who it is. Brandy, has the Office of Naval Research been involved in the process OSD uses to review tech associated with autonomous weapons, citing Section 8000.09? Has any Navy tech been submitted for review? What does the process look like from your end?
I think you mean 3000.9, basically the DoD directive on the use of autonomous weapon systems. Absolutely, certainly we do. The ONR funds research. So the Office of Naval Research, we focused mostly on 6.1 and 6.2, which is early, very early stage development. There is some development. There is some later on 6.3 and a higher technology readiness level funding as well. But anytime, any kind of weapon system when you're using autonomy, and it's interesting if you read it, right? You're like, what we will not allow, the DoD directive states that there is no use of autonomous weapon systems without human oversight for certain use cases, and we define when they are and are not used. In particular, for example, for those of you that know what a CWIS is, a close-in weapon system, CWIS, they sit on ships and they're Gatling guns and they're designed to shred, something like 6,000 rounds a minute, last point defense of an incoming missile or something. That is, once you turn that thing on, this is one thing about using AI, right? It locks in on any metal in flight around the ship and opens up with a Gatling gun and shreds it. Once you turn it on, it's not human controllable because it's designed to shoot down an incoming missile that's moving at, potentially supersonic speed or moving very quickly and maneuverable. That's an autonomous weapon system. It is legal and allowable because it is only designed to be used against materiel, not a human target. Another type of autonomous weapon system that would be like flares and things like that coming off an aircraft, auto-deployed flares. Those are legal because they're not used against human targets. The DoD directive goes in and delineates in significant detail when and where you can, what counts as an autonomous weapon, when and where you cannot use them without human oversight. And then lays out a policy to get a system cleared both for testing and evaluation and then later for acquisition. So most of the work we do is around the TE, the testing and evaluation phase, but really it ends up, it's when it gets closer to the acquisition is where it more gets in. And ONR is, like I said, more basic research focused. We certainly are aware of it and use the process when it's needed for a particular use case.
Great, thank you. My apologies if I mispronounce, from Jekyll. Considering the data triad, data at rest, data in transit, data in use, what is the Navy currently addressing the protection of data in use to prevent? I think he means how is the Navy currently addressing the protection of data in use to prevent our adversaries from gaining insights on our intentions for which we are accessing such data?
I think the same way we've always done it, right? The British were cagey about breaking the German codes, cagey about what radar could do. Same general thing. Your triad there, your data security triad is a little bit more of a cyber problem than an AI problem, but it gets into it as well, because one of the things that AI we look at is, okay, one of the things we didn't really talk about is you can poison a model. You can inject bad data into a model before it's trained, and now the model is trained on bad data. And there's also ways of, if you understand how a model works, you can tweak the real world thing. I think people may have seen images of where the stop sign, you put a piece of duct tape in a certain part on the stop sign, and the computer vision model thinks it's a speed limit sign. It's a form of the brittleness of the model to some extent. That is part of the AI engineering. How do you take into account what an adversary might do to your data, or how do we do it to their AI, right? If they're deploying AI and they're using AI to monitor us, can we figure out how they're doing it and tweak our signal? Can we tweak something so that it messes up their AI? There's a lot of that going on, and there's a lot of that thinking about how that would work. I'll leave it at that.
Yeah, I'm kind of looking at his question or hers. My apologies if I've mistaken that. And I think this is even a secondary level. It reminds me of the watch the Pentagon getting pizza. Therefore, we know something's going on the next day. It's almost like if we're accessing a certain amount of data in a certain domain, can people extrapolate from that what we're doing? So that's a really interesting question. I don't know that we have an answer for it right now, other than, like you pointed out, our general precautions we already have in place. But an interesting secondary implication of our use of data. Next question, Tulu A, are there additional DoD funds or resources that can be available to branch specific projects, say, for example, Army Legal trying to implement generative AI in case management and analytics?
Say that again real quick.
Yeah, are there additional DoD funds or resources that can be available to branch specific projects, say, for example, Army Legal trying to implement generative AI in case management and analytics? It almost sounds like if you can add to the chat, maybe we're not catching this right. It almost asks if there's resources for us to identify a best of breed effort and then leverage it and expand it to an enterprise-wide initiative. I would say you can stab this one. Mine would be yes. There's always funds and resources, but I'll toss over to you.
I think part of it is, like, right now, generative AI is not authorized for use in the DoD unless it's distro A data, right? So if you're putting in, let me go through some details. So ChatGPT, whatever you enter into ChatGPT is recorded and saved by OpenAI. The same way that Google saves your Google searches to build a profile, whereas DuckDuckGo does not, allegedly. So they say. The OpenAI saves the data, and it potentially uses it to continue to train the model, which means that if you put sensitive data, you put something into ChatGPT, into the question, there's a potential for that, whatever you put in, to be used to train the model and get outputted later. If you put in, like, who was the first person to figure out the Eiffel Tower was 5,000 feet tall? It could potentially update the model somewhere down the road of, like, if enough people did that ChatGPT now thinks the Eiffel Tower is 5,000 feet tall. That one's not the case. But if you were to put in other sensitive data that, it could, and somebody later asks, how tall is the Eiffel Tower? It goes, oh, I think I saw someone say it was 5,000 feet, and that's what it spits back out. The same way of data going in can go out. So one thing is, we don't put DoD, unless it's distro A, you don't put it in there. Two, there are commercially available large language models that claim they do not save the input, right? They're like, hey, whatever you put in here, it's immediately deleted. Not that I don't trust them, nor do I not trust DuckDuckGo. It's just that I've never verified that that's true. So same thing with these models. So when you want to use them to build all kinds of stuff, we had a lieutenant in the Navy build. They're not that hard to build if you know what you're doing. And there's some open source versions you can take and then tweak and fine tune them. He took an open source version and fine tuned it on a bunch of Navy publications. Maybe like technical manual publications about how to fix structs and things like that. To make it, if you ask it a question of like, how do I fix the struct, it'll spit out the answer because it now has all that knowledge in it. The same thing with legal, you could potentially do it. That system he built is standalone, right? It's not on the internet because he had to put it offline when basically once we started to put some of the sensitive information in it, we no longer share it on the internet. The legal thing is the same thing. It's like lawyers, a lot of people would love to use it. One of the things we're looking at is using it for fit reps and award write-ups, right? Throw a couple bullet points in, it'll spit out a pretty good award write-up. You may need to do the final pen on it, but that goes back to democratizing the ability to create these things. I think that Task Force Lima that was just set up is supposed to get after this. And then how would we use this? How can we, like lawyers that write all these massive briefs, lawyers that use the legal industry is using this to like take all legal case history, take a version of a large language model and fine tune it on legal case, and then use it as a query question. Basically you ask it, you can chat with it about, well, what did this case say? And what did that case? Are there other similar cases that would apply to this? And you can have like having a paralegal that knows all the cases. And again, this is dull, right? So those junior lawyers that spend hours researching cases, kind of the same way we used to way back when it was very hard to find academic articles if you were in academia, and then LexisNexis, and it got easier to search. The dullness of the part of the job was taken away and replaced by a machine. Kind of danced around the question there. The short answer is there are no DoD funds right now. The closest thing we've got looking at it is Task Force Lima. Over.
Very interesting. As someone with a legal background, I found that discussion, that insight very interesting. I would point out to everyone that you've got to remember that at least the generative AI that we have right now is probability, right? It's probability based. What's the probability that this is the next word in the sentence? And they've also been trained to produce a narrative that is pleasant to humans. As someone with a legal background, I would like to point out that that does not equate to analysis. And as dull and boring as legal writing may be, we probably want to balance what sounds pleasant and what is probabilistic against what is correct. So I don't think they've replaced the analysis part yet. That's just my that's my observation thus far on generative AI, large language models in the legal world. So is there any other questions in the chat for Dr. Long before we wrap up today's session? I'm not seeing any other questions, so thank you for joining today. We're grateful for your support to DoD Innovators and Innovation Connect. We have several pioneering projects underway and anticipate featuring even more in the future. Join us for our next Innovation Connect event on 14 September, which will include a special presentation from Ms. Jennifer Swanson, Deputy Assistant Secretary of the Army, Office of Data Engineering and Software. Thank you, Dr. Long. Thank you to all our guests and all the thought-provoking questions. And we will see you next month. Thank you.